Hello everyone. Today we are going to discuss on causality, stability of the system using Z-transforms. So in Z-transforms, causality is when impulse response h of n is equal to 0 for n less than 0. So this is the condition for causality. That is, ROC must be outside the outermost pole. So right-sided sequences, we can call them as causal sequence. That is, impulse response is a right-sided sequence, then we can say the system is a causal. Okay. Similarly, stability, poles of h of z lies inside the unit circle in the z plane, then that system can be called as stable. So all the poles of h of z should be inside the unit circle, then system will be stable. Okay, they are independent. The system which is causal can be stable or it may not be stable, whereas the system which is stable, it can be causal or it may not be causal. So that is a condition. Now the third one is the system is both stable and causal. It is when ROC must include the unit circle and it must be outside the outermost pole. So all the poles should lie inside the unit circle in the z plane. Okay, all the poles should be inside the unit circle, then only we can able to satisfy stability and causality for the same system. Let us go through an example. Determine whether the system described below is causal and stable. So this is the system given. H of z is equal to 2z plus 1 divided by z square plus z minus 5 by 6. Correct? H of z is equal to 2z plus 1 z square plus z minus 5 by 6. Okay. Regarding this, what we need to determine? We need to determine whether it is causal and stable. So condition is, first we need to find out what are the pole locations. Okay, pole locations we need to find out. So it is z plus 5 by 4, z minus 1 by 4. If we simplify using the ax square bx plus c equation, what we get is z plus 5 by 4, z minus 1 by 4. These are the roots or values of z. So what are poles here? Poles are z is equal to minus 5 by 4 and z is equal to plus 1 by 4. Okay, if you equate it to 0, then you will get that, this one as well. So minus 5 by 4 is obviously greater than 1. 1 by 4 is, say 1 by 4 pole is here, minus 5 by 4 is, it might be here, minus 5 by 4, and our unit circle might be here, unit circle, this is 1. Okay, so here you can see clearly that in the z plane, in this plane, all the poles are not inside the unit circle. That's why it is not a stable system. Okay, we can draw another circle like this and we can show that ROC is outside the outermost pole. This is possible. So we can make it causal. It may be causal, but it cannot be stable. Okay, that is what the result given here. So you can see poles are outside the unit circle. This pole is outside the unit circle, whereas this is inside. So it is not a stable. That's why it is not both causal and stable. It can be causal because we can draw at 1.25 one circle and 1.25, that is 1 by 4, and we can show that the ROC is outside outermost pole 1.25, and this will become causal only, not causal and stable both. Okay, so that is what the final conclusion we get from this problem. Okay, this is the first one. Now let us look into the second one.